So this is the week 8.2 max patch, which you can download and follow along. And we're going to talk about modulation, different forms of modulation. And the two main forms of modulation are frequency modulation and amplitude modulation. And frequency modulation can be used as a synthesis technique, but it is most commonly used to create vibrato. So when we talk about frequency modulation, what we're really talking about is, especially if we're talking about how it might be used in vibrato, is a periodic adjustment to the frequency of a sound by making that frequency periodically move from being slightly higher to slightly lower and slightly higher and slightly lower. And this periodic change of frequency happens at a relatively low rate. In other words, think about if you're playing a stringed instrument and you're creating vibrato. Well, you're moving your finger along the string so that the frequency changes slightly, but you're not moving your hand or your finger, 300 times a second. You're moving your finger maybe 4 or 5 or 6 times a second. So when we convert this into a control in max MSP, we have to think about the kinds of values that would make sense for a vibrato. So we're going to use an oscillator, and that oscillator is going to oscillate back and forth, so a cycle object, and it's going to do that maybe 4, 5, 6 times a second. It's not going to do it 150 times a second. Okay? So what we call the frequency of that oscillation will be relatively low. It's a low frequency oscillation. And the depth of that adjustment to the frequency. So if we think about the frequency, let's say we're playing A440. As we move our finger one direction, the frequency changes to maybe A444, and then it goes back down to A440, and then it goes down to maybe A436, and then up to A440 and A444 and A440 and A436 and so on. So it changes the frequency of the sound, but it changes it relatively little, unless you're moving your hand, up and down the entire string. So vibrato is a form of what we call frequency modulation, and it's a frequency modulation where both the depth of the vibrato and the frequency of the vibrato are relatively small. Okay? So this is the way to think about that with frequency. This is the fixed frequency. We're periodically going to add a little, we're going to make it waver slightly. Right? And that wavering of the frequency represents a vibrato. It simulates taking your finger and moving it slightly along a string and changing the exact position of the center frequency. Okay? So here I've encapsulated an additive synthesis, just a simple additive synthesis sound into an abstraction called additive, which you can also download. And it is really simple. It has a trigger which goes and bangs all of these envelopes, and it's got fixed frequencies, 400, 800, 1200, 1600, and 2000. So the first, second, third, fourth, and fifth partials of a sound, and each one has a different envelope. And they're just sort of arbitrarily put in there. You can change those envelopes to make them more interesting. I also have a domain, the ability to set the domain. The domain is set to 5,000 for each of these. They're all added together, and a signal comes out. And then in here, this is the part that I wanted you to notice. I have an input, which is the vibrato signal. And it goes into each of the cycle object. Well, it goes into an addition before the cycle object. So let's just we'll take the 400 as an example. So we're going to add whatever comes in from the vibrato signal to 400. And so it's going to be small numbers like 0 and maybe 4 and 3, 2, 1, 0, -1, -2, -3, -4, and so on. So we're basically the vibrato signal we need to add to all of these partials is going to be small numbers in cycles per second that are going to go slightly, going to cause us to go slightly above the center frequency and slightly below that center frequency. Okay, so just looking at this and seeing how it's done, you can see that we really want relatively small values, maybe up to 10 cycles above and 10 cycles below. Okay, now we'll close that up and we'll come back here. So these two controls are going to control our vibrato. And here you see our cycle object. And this cycle object has a slider here, and it basically goes up to 9, from 0 to 9. And that is going to be a cycle. Now we know what cycles do. They go from 0 to 1 to 0 to -1 at some rate, okay? And so we get that out of a cycle at some rate. It might be 4 times a second or 7 times a second. Not very fast, but it's always going from 0 to 1 to 0 to -1. And then we need to multiply it by some value so that that 0 to 1 to 0 to -1 to 0 becomes something else. Let's say we put 8 in. Let's put 10 in. It's easier. We'll put 10 in as a multiplier. Well, now the cycle, instead of going from 0 to 1 to 0 to -1 to 0 and so on, it's going from 0 to 10 to 0 to -10 to 0 to 10. Now, so those values, 0, 10, 0, -10, 0, 10, 0, -10, which are happening at, let's say, 4 times a second, are going in here, and they are being added inside that to each of these frequencies, frequencies that are being sent to the cycle object. Okay, so this one, which was 400, is actually going to go from 400 to 410 to 400 to 390 to 400 and so on. And that will create a vibrato for us. So I'm going to use these two values. The frequency is 4 times a second. The depth is 10, which basically means plus or minus 10 to the frequencies we have in our subpatch or our abstraction. And the result will be something like this. So you're getting a vibrato. If I want the vibrato to go faster, put it up to 9. If I want the depth to be greater, I put up the depth. Okay? The tremolo. So whereas vibrato is a periodic adjustment to the frequency, and we were sort of looking at it, we start at 400, we go a little above 400, a little below 400, back and forth like this. Tremolo is a periodic adjustment to the amplitude of a sound. So if we think about a waveform, we're just basically compressing the waveform and expanding the waveform through amplitude controls. And we're doing that in a periodic fashion. So what we do here is we also use a cycle object. But you remember that cycle objects have values which go from 0 to 1 to 0 to -1 to 0 and so on. And so we need to say, well, how many times do we do that? And how do we turn this into an amplitude adjustment? Well, what we do is we add 1 to the output from a cycle. So now instead of going from 0 to 1 to 0 to -1 to 0, it goes from 1 to 2 to 1 to 0 to 1 to 2 to 1 to 0. right? And then if we multiply that by 0.5, we now go from 0.5 to 1 to 0.5 to 0 to 0.5 to 1 to 0.5 to 0. So we're basically allowing ourselves to go from 1 to 0 and 1 to 0 in our sine wave. Okay? So that's just a little bit of math to convert going from basically we don't want negative values. We want all this to be a positive. And so if we do that little bit of math, we now have just a cycle that's going between 0 and 1 in a cyclical fashion. And if we multiply the output from our additive synthesis module by that factor, then we essentially are taking the amplitude and we're doing this to it. We're basically bringing it down to 0 and bringing it up and bringing it down to 0. And we're doing that a certain number of times a second. So let's give ourselves, let's take the vibrato off and we'll give ourselves tremolo at 5 times a second. And you can see when you look down here at the output that it is tremolo, it is amplitude modulation, it is not frequency modulation. If I take this off and I put my frequency modulation back on, you can see that this is basically stable. There's a little bit of difference there, but not like there is with this. Okay? Now, this is just a simple example because, in fact, if I wanted to do proper vibrato, I would probably take into consideration, like, what is the frequency, what is the fundamental frequency, and I would probably use that to adjust my vibrato speed and my vibrato depth. You know, you're more likely to have faster faster vibrato with slightly higher frequencies than lower frequencies, and because of the way intervals work, you would use a wider depth if you have higher frequencies. In other words, if you go up and if you have a frequency that's at 200 and you go up above and below by 10 cycles, that's a much bigger interval than if you are at a fundamental frequency of 2000 and you go up and above and below by 10 cycles, right? Whereas down at 200 or 100, that's a big interval. So you want to adjust your vibrato depths and frequencies based on the pitches that are involved if you want to do it properly. Okay. Let's see. So let's do the ring modulation. Ring modulation is a particular type of amplitude modulation, but what we actually do is we modulate with the cycle. We modulate the entire additive synthesis signal or the entire sound, and so we have a cycle object. This is really just a way of controlling the frequency so that I can smoothly change frequency. I put it into a line so that I get smooth transitions when I set frequencies. But this essentially is a cycle at some frequency which is being multiplied by the entire additive synthesis sound. Now, what happens, and this is how we do ring modulation. What happens with ring modulation is whatever frequency is put in here. Let's say I'm going to put 100 in. This frequency, when it's multiplied by an incoming timbre, will create frequencies that are the addition and subtraction of this frequency. In other words, if I have 400 coming in, I get 500 and 300. And if I have 800 coming in, I get 900 and 700 in my ring modulation. So it creates this very interesting metallic timbre in sound. So I'll just play that. And when I move the frequencies, you can hear the sort of heterodyning effect where there are two frequencies. One is going up and the other is going down. Okay, so that's ring modulation. Down here at the bottom, there's just a slightly altered version of the additive synthesis abstraction. This one's called additive 2, and it takes 2 arguments. So you can see now everything is the same except that the arguments that I put in here, the 100 and the 5,000, get used for the partials. So the 100 is put in all of these places, and it's multiplied by a partial number. Okay, so it actually, although the default values are 400, because it's in a signal object, that'll get updated. So this will generate a fundamental of 100 with a duration of 5,000 milliseconds. And if I change this to 1,000, all of these values have been changed to 1,000. Okay. And another one here, this has got an input so I can change the domain as well as a vibrato signal, and it takes a pitch in as its input. So this one's a little bit more flexible. I can put 100, 200, change the envelope. Change it back. And you can see, you can imagine, it would be fairly easy to take a K slider, an M to F object, put it in here. And this should actually be a floating point number, not an integer, because I'm doing a slight bit of truncation of my values. Okay, so this one, obviously what we need to do here is to bring in pitches, and this pitch is going to a trigger, and this trigger is sending all of those pitches to all of these signal objects. So it's resetting those signal objects to different values, multiply them by 2, 3, 4, 5, and then adding the vibrato values to that, and then adding them all together so that they go out. And then the last thing that happens when a pitch comes in is the bang comes out and goes to another bang, a trigger bang, which triggers all the envelopes, right? And it's also set to have the vibrato. So if I wanted to add my vibrato to this, I could do this and set my vibrato. Right, so there is a version that you could look at for the upcoming assignment. Base it on something like this. It doesn't have to be an abstraction; it can be a patch. But it takes pitch as input, is capable of having different durations, and it is capable also of having a vibrato. So you can look at that additive 3 patch. Okay, and that's week 8.2.